All right, this is AP Calculus ABB, Unit 2, Definite Integrals, Lesson 4, Definite Integrals and Antiderivatives 2. This particular lesson involves at least 4 major objectives, so I'm likely going to split this in at least 2, maybe 3 different recordings. So, because there's a lot of information, a lot of problems to work through. All right, so let's deal with the first, and that is the concept of integrals and area. So if you find the integral from a to b of f of x dx, you essentially are finding the area between f of x and the x-axis. Okay, so let me give you an example. Let's say I'm going to find the integral, and this is a common problem on the AP test. The integral from let's do from 0 to 4 of the square root of 16 minus x squared dx. Now, you may recognize this function, you may not, but let's write it out. Y equals square root 16 minus x squared. Let's square both sides. Y squared equals 16 minus x squared. Add x squared to both sides. X squared plus y squared equals 16. Now, hey, that looks familiar. X squared plus y squared equals 4 squared. You may recall x squared plus y squared equals r squared is the equation of a circle centered at 0, 0 with radius r. Okay, so essentially what this is this is the top half of a circle. You can verify it if you want using Desmos. So square root 16 minus 4 squared minus x squared. Okay, and it's a circle of radius 4, but it's only the top half because the square root function only allows you the positive root of. If you want the other half, you're going to want to do negative square root 16 minus x squared. Okay, and you get the other half. As opposed to in Desmos, you can graph a relation y squared equals 16 and get the same thing, total circle, right? But that's not a function. And so using geometry, we can actually answer this question without having to do anything fancy schmancy with the square root, because actually finding the integral of a square root function with a function of x inside the square root is quite tricky. There are some techniques such as u substitution, such as partial fractions, and other things that we're going to learn later on, but this is a very difficult integral to find. But it's not difficult if you recognize the geometry of the situation. So we've got literally a circle from 0 to 4. Okay, and it's the top half of the circle from 0 to 4. And we are finding the area under the curve. Okay, and the solution that I'm proposing here is that we use what we know about the shape. The shape is a quarter circle, 1/4 of a circle, and the area of a whole circle is pi r squared. So the area of a quarter circle is 1/4 pi r squared. So if a geometric shape is made by your function, you may use the formulas you know for the area of the geometric shape. So this is 1/4 pi times r squared. R is the radius of 4 squared. 4 times 4 is 16, and 16 divided by 4 is 4 pi. Okay, and so that is our solution. There's no need to go into the algebra or figuring out the antiderivative of such a complicated shape. So be aware of geometry and shape. That's point number 1. Okay, point number 2, since we're only at 5 minutes, we'll go ahead and go into the second point here. and that is this. There are some identities involving integrals and antiderivatives that are useful for finding other antiderivatives. So for example, if I have some function called f of x, and I start with some value a, okay? If I go to the right, all right, if I go to the right from A to B, and that has an area M, then we notate that by the integral from A to B of f of x dx. That is M, right? But what if I reverse the order from B to A? Now we're using B as the start value and we're going left. In that case, what happens here is the value is negated. It actually becomes a negative area. All right, so that's identity 1. So if the integral from A to B of f of x dx is M, then the integral from B to A is negative M. And it just changes signs when you switch. It's kind of like this. B minus A equals negative A minus B. When you switch the order of subtraction, which is essentially what's going on, when you switch the order of subtraction, you are in essence factoring out a negative. You're changing the signs on both subtrahends. Okay, that's option 1. What if we have this? Now let me redraw. What if we have a function f of x, and we have some value a and some value b and some value c? Okay, and let's say the integral from a to b is m and the integral from b to c is n. That would be notated this way. If the integral from a to b is of f of x dx equals m, and the integral from a to b of f, or b to c of f of x dx equals n, then the integral from a to c, so the whole integral is of f of x dx, is m plus n. Okay, and here's how you might see that. You might be given something like this, and let's bring up a new slide here. So let's say we know the following: the integral from a to b, or from 1 to 5 of f of x dx is 16, and the integral from 5 to 9 of f of x dx is 4. Then what is the integral from 1 through 9 of f of x dx? This is the simple version, 4 plus 16. Okay. What if I tell you this? What is the integral, or actually what is the integral from 5 to 1 of f of x dx? Well, that would be negative 16, right? Because we just switched the 1 and the 5. You can do this for subtraction as well. Let's say the integral from 2 to 4 of g of x dx is negative 6, and the integral from 2 to 3 of g of x dx equals 4. Okay? Then what is the integral from 3 to 4 of g of x dx? Now I can just subtract, or I can use this logic. The integral from 2 to 3 of g of x dx plus the integral from 3 to 4 g of x dx equals the integral from 2 to 4 g of x dx. Substitute. 2 to 3 is 4. 3 to 4 is unknown, so leave it. 3 to 4 g of x dx. And 2 to 4, or 1 to, 2 to 4, can't read my own writing. 2 to the 4 is negative 6, so subtract 4, the integral from 3 to 4 of g of x dx equals negative 6 minus 4, or negative 10. Okay, and all of that wasn't entirely necessary, just realizing that 3 to 4 is basically 2 to 4 take away 3 to 4, 2 to 3, so it's, you could simply do negative 6 minus 4, negative 10. Okay, this is just a little more thorough and demonstrating that we're using the rule of addition, which can be translated into the rule of subtraction. Okay, that said, I'm going to go ahead and stop the video here. There are two more objectives, the average value and finding definite integrals formally. Okay, so we're gonna do those here in the next video.